So is 8 a factor of 72?
Yeah.
Yeah? What? 8 times 9 is 2. Is x minus 8 a factor of x squared plus 2x minus 80? Yes, it's x plus 8, or x minus 8 times plus 10. And sure enough, that's a factor, sure. Is 13 a factor of 27,846?
Yeah.
How do you know? Assuming you don't have a calculator, what do you do?
Right?
Divide would be a way of finding out, right? That's factoring, guys. So if I want to find out if x plus 3 is a factor of that polynomial, I got to divide. I'm going to do a little comparison here. In one column, I'm going to do 13 into 27,846. And in the other one, I'm going to divide x plus 3 into x cubed minus 4x squared plus 2x minus 6. A little long division here. Now I'm going to ask slightly different questions than you usually do as we go through this. The questions will be a little tiny bit different than your old long division, but it's the same process. I want to make 13 look like 2. Can I do that? How about 13 look like 27? Can I make 13 look like 27? But do I need to multiply by 13 to make it look like 27? I multiplied 13 times 2 to make it look like 27. Notice I wrote the 2 above the 7. 2 times 13 is 26. And you must change the sign and add. I know you guys like subtraction, but we don't do subtraction in algebra. I want you to change the sign and add. And you get 1. And we bring down 8. We're going to do the same thing over here. I want to make x plus 3 look like x cubed. I can't make it look like exactly like x cubed because it's got another term in it. I can make it look a little bit like x cubed minus 4x squared. What do I need to multiply by x to make it look like x cubed? X squared. I write the x squared up above the x squared term, and I multiply times both parts. This gives me x cubed plus 3x squared. Now, I must change the sign and add. When you change the sign, you have to change the sign of both parts. A very, very common mistake, and the most common mistake made on this part of your assignment is forget to change one of the signs, but forget to change the other. You must change the sign of both parts and add. What do we get?
Negative 7x.
Negative 7x squared. Bring down the plus 2x. How do I make 13 look like 18? I'm going to make 13 look like 18. What do I have to multiply by? 1 times 13. I change the sign and add, and I get 5 times 4. Over here, I want to make x plus 3 look like negative 7x squared. What do I need to multiply by x plus 3 to make it look like this? Negative 7x times x plus 3 is negative 7x squared. Negative 7x squared minus 21x. And what's the next step? Change the sign and add. You must change the sign of both parts. That is 23x minus 6. On this one, how do I make 13 look like 54? Multiply by 4, and I get 52. Change the sign and add. You get a 2, bring down your 6. This one worked out a little nicer, huh? What do we get up here? 2, that's 26. We change the sign and add. We get a 0 remainder, which means that 13 is the factor of 27,846. Now, I need to make this look like this by multiplying by 23. 23 times x is 23x. 23 times 3 is 69. This is the most common place for errors. On the very last step, everybody always remembers to subtract these two and forgets to change the sign. They'll skip that step every time. I'd say 90% of the reason students miss this is because on the last step they forget to change the sign. It's like, 90% of your problems come from right there. And what is my remainder? Negative 75. Now, we have two things that we used to do with remainders, one or the other. You can write remainder, negative 75, or we can turn it into a fraction over x plus 3. So you can write this. Remainder, negative 75, that's fine. Or you can write it as x squared minus 7x plus 23 plus negative 75 over x plus 3. Either way is correct. Doesn't make any difference which way you write it. Generally, we leave it like this, but sometimes we write it like this. Depends. Either answer is correct, though.